Astronomers have observed some very fast spinning brown dwarfs. Through the use of data from NASA's Spitzer Space Telescope, scientists have observed 3 fast spinning brown dwarfs. Most of these brown dwarfs are more massive than most planets, but are not quite heavy enough to ignite like stars. Brown dwarfs are cosmic in-betweeners, and although they are not well known as stars and planets, to most persons they are thought to number in the billions in our galaxy. It should be noted that the astronomers consider these 3 brown dwarfs to be the fastest spinning brown dwarfs ever discovered. In a recently published study, it was mentioned that the new speed measurements argue that these 3 rapid rotators could be approaching a spin speed limit for all brown dwarfs, beyond which they would be broken apart. The rapidly rotating brown dwarfs are all about the same diameter as Jupiter, but currently exist between 40 and 70 times more massive. They each rotate about once per hour, while the next fastest known brown dwarfs rotate approximately once every 1.4 hours, and Jupiter spins once every 10 hours. Based on the size of these brown dwarfs, it means that the largest of the 3 brown dwarfs whips around at more than 60 miles per second, or 100 kilometers per second. Or it could also be approximately 220,000 miles per hour, which is equated to 360,000 kilometers per hour. Speed measurements for these brown dwarfs were taken from data gathered from Spitzer. This telescope was retired in January 2020 by NASA. The brown dwarfs were discovered by the ground-based 2-micron all-sky survey, or the 2MASS, which ran as a program until 2001. The research team then corroborated their unusual discoveries through observations with the ground-based Gemini North and Magellan telescopes. Brown dwarfs, in a similar way to stars or planets, are already spinning when they are formed. As they cool down and contract, they spin faster, in a similar way to when a spinning ice skater draws her arms within her body. Scientists have also measured the spin rates of approximately 80 brown dwarfs, and they vary from less than 2 hours. And this also includes the 3 new entries for brown dwarfs. The variation lasts from 2 hours to tens of hours. With so much variety among the brown dwarf speeds already measured, it surprised the researchers that the 3 fastest brown dwarfs ever discovered have almost the exact same spin rate, which is approximately 1 full rotation each hour. This cannot be attributed to the brown dwarfs having formed together or being at the same stage or phase in their development, because they are physically quite different. One brown dwarf is a warm brown dwarf, one is a cold brown dwarf, and the other falls between the 2 of them. Since brown dwarfs cool as they age, the temperature differences between these brown dwarfs are quite different. It should also be noted that these brown dwarfs are at different ages. The research team have said that this may just be a sign of coincidence. They believe that the members of the speedy trio have all reached a spin speed limit, beyond which a brown dwarf could break apart. All rotating objects generate centripetal force, which increases the faster the object spins. On a carnival ride, this force can threaten to throw riders from their seats. In stars and planets, it can rip the object apart. Before a spinning object breaks apart, it will often start bulging around its midsection as it deforms under the pressure. Scientists call this ablation. Saturn, which rotates once every 10 hours in a similar way to that of Jupiter, has a perceptible ablation. Based on the known characteristics of the brown dwarfs, they likely have similar degrees of ablation, according to the research that has been presented. Considering that brown dwarfs tend to speed up as they age, these objects are regularly exceeding their spin speed limit and are regularly being torn apart. In other rotating cosmic objects like stars, there are their natural braking mechanisms that stop them from destroying themselves. It is not clear whether or not similar mechanisms exist in brown dwarfs. It would be pretty spectacular and fantastic to locate a brown dwarf rotating so fast as it's tossing its atmosphere out into space. Many are of the belief that so far they haven't found such an object. They believe that this must mean that either something is slowing the brown dwarfs down before they hit that extreme limit, or that they cannot get that fast in the first place. The result of the research supports some sort of limit on the rotation rate, but they are quite unsure of the reason for this. The maximum spin rate of any object is determined not only by its total mass, but by how that mass is distributed. That's the reason when very rapid spin rates are involved. Understanding a brown dwarf's interior structure becomes increasingly important. The material inside likely shifts and deforms in ways that could change how fast the object can spin. Similar to gas planets such as that of Jupiter and Saturn, brown dwarfs are composed mostly of hydrogen and helium, but they are also significantly denser than most giant planets. Astronomers and scientists alike are of the opinion that the hydrogen in the core of a brown dwarf is under such tremendous pressure that it starts behaving like a metal rather than an inert gas. It has free-floating conducting electrons, much like a copper conductor. That changes how heat is conducted through the interior and with very fast spin rates. This may also affect how the mass inside an astronomical object is distributed. This state of hydrogen or any gas under such extreme pressure is still very enigmatic. And in a similar way, researchers are of the opinion that it is extremely challenging to reproduce this state of matter, even in the most advanced high-pressure physics laboratories. Like, comment, share, and subscribe. Let me know what you think about the fascinating discovery of these speedy brown dwarfs. Thanks for watching. Goodbye.